Okay, Prop 18 says, in any triangle, the greater side subtends the greater angle. And what that means is that in any triangle, if you take two sides, whichever side is longer is going to be opposite the larger angle. So take, for example, if we look at, in this triangle, AC versus AB, the claim is that since AC is longer, the angle that is opposite AB is going to be larger than the angle that is opposite, sorry, did I say AB? The angle that's opposite AC, which is angle B, will be larger than the angle which is opposite of AB, which is C. So the larger side is opposite the larger angle. And this is kind of an interesting proof. I sort of started recording this a second ago, and then I had to stop because I realized something. And so I'll just sort of run through the proof, and then I'll say what it is that kind of hung me up. Okay, so to begin, we assume that we have some triangle ABC, and moreover, we assume that side AB is larger. Sorry, not AB. AC is larger than AB. And that's just without loss of generality. It doesn't matter. So assume that AC is longer than AB. All right, so then the claim, and I'll just kind of write this. Claim is that angle ABC is larger than angle ACB. That's really what we need to prove. See if I can focus that a little bit better. Oh yeah, maybe that's a little better. All right. So, okay, so how does it go? Well, since AC is longer, we can, I guess we can cut off on AC AD, such that AD equals AB. So since AC is greater than AB, place D, and I should be specific here, place D on AC, such that AD equals AB. And again, this is, let's see, this should be cited, right, yeah, it's Proposition 3. Proposition 3, forgot the little I in there, but it's also just, you make a circle and see where they intersect. So I guess it's going to be about right here. I'll maybe make some indication of this circle just to make the diagram a little bit more interesting, I guess. All right, so here's our point D, where AD is equal to AB. So their radii have the same circle. And then we join BD. So we just make this line. So we're splitting our larger triangle into two smaller triangles. What next? All right, and then since the angle ADB, right, so ADB, this angle right here, is an exterior angle to this sort of bottom triangle, which means that we have a proposition that says that this angle, this exterior angle, is larger than either of the interior or opposite angles. So, what should we say? Since angle ADB is an exterior angle to triangle BCD, then it follows that angle ADB is greater than both of those interior and opposite angles, but in particular it's greater than the angle DCB. So, right, what did we just say? Angle ADB, this angle right here, is larger than this bottom right angle, DCB. And this is what Euclid writes, and then here I'll just kind of make a note that angle DCB is angle ACB. Right, so we're getting some part of what we need here. We're getting close. Okie dokie. Right. And this was this exterior, it being an exterior angle is greater than the interior angles. This is from Proposition 16. So it's really just the inequality part, not the last little bit that I added on. But that comes from Proposition 16. Okie dokie. What's next? But the angle ADB is equal to the angle ABD. ADB is equal to ABD. Why is that the case? Well, by construction, this is an isosceles triangle. And we have a proposition that says that the angles at the base of an isosceles triangle are equal to each other. So, but we know that angle ADB is equal to angle ABD. And let's see here. Did I write down what proposition it was? Yeah, it was Proposition 5. I don't think that that's actually justified. Yeah, in my text, this part is not justified, and it should be, but it's Proposition 5 that gives us that fact. Since AB is equal to AD, it's an isosceles triangle. Well, we just said that ADB is greater than ACB, and ADB is equal to ABD. So angle ABD, is that what I want? Yeah, angle ABD is greater than angle DCB. Or, more to the point, since DCB is equal to angle ACB, it's greater than angle ACB. Right? So all that we've said so far is that angle ABD, this angle right here, is larger than angle ACB over here. But, and Euclid just kind of states, let's see, so what does he say? He says, therefore angle ABD is also greater than angle ACB. So that's what we just stated, and his next statement, his following line says, therefore, he does this again. He's done this in another proposition where I said, yeah, this is a kind of a funny thing to say, but it does make some sense, although he doesn't justify it. He says, therefore, because of this, therefore the angle ABC is much greater than the angle ACB. And to me, I look at that and I go, wow, he should have justified that a little bit more. The reason that he didn't is because they felt that pictures were, part of the proof. Like if you kind of draw out the picture in a way where you can sort of see why this is the case, they felt, this is my interpretation, they felt that, oh, it's just kind of intuitive, it's obvious, we maybe don't need to state that. Although me personally, I think it should be kind of stated a little bit more. Because, so I'll write my proof and then I'll write in what I would personally, if I was the author of all of this, what I would have added to make this really clear. So, therefore, we arrive at angle ABC is much greater. Angle ABC is much, so I'll just say it's greater. Angle ABC is much greater than angle ACB. Okay, so what did we find? We found that angle ABC is much greater than angle ACB. Why? Well, I might just note that angle ABC is equal to angle ABD plus angle DBC, right? So angle ABC is this full angle, so it's really angle ABD plus angle DBC. And we just stated, before this, we stated that angle ABD is greater than ACB. So obviously ABD plus angle DBC is going to be larger than angle ABD. I guess, yeah, that's how I'll write this out to make it just insanely clear. ABD plus angle DBC is obviously greater than angle ABD, since both are positive, and we just found that angle ABD is greater than angle ACB. So the result follows. Yeah, and I guess actually now that I'm thinking about it, at the beginning of this, I was saying, oh, I kind of got hung up on some things. But actually, now that I'm kind of looking at this proof, it does seem pretty clear and straightforward. Yeah, in any triangle, the greater side subtends the greater angle. I suppose I'm just looking at the next propositions because, you know, this is just stated for like the way that this is stated. I'm just like talking now. I mean, the proof is done. But the way that this is stated is saying that, yeah, grab any two sides of a triangle, whichever one of those sides, if one of those sides is larger, that side is going to be opposite the larger angle between the two angles that they're opposite of. But this also can kind of be, I guess, sort of broadened to say that in any triangle at all, the largest side is going to be opposite the largest angle. So it doesn't even have to necessarily be between two sides. It's of like all three sides. This is still true. All right, there's that. And it's a proof. It's a proof type proposition. So yeah, it gets a QED, therefore, etc.